we'll come back to motion diagrams and do more of those later, but for now I want to introduce one of the most important variables that we're going to be dealing with a lot this semester, and that is called displacement. Okay, so displacement means something very, very, very specific in physics, and it's a term that we're going to use a lot. So what I want you to do is in your notes, I want you to have a very clear definition written down for displacement. And then as you watch other videos and I use the word displacement and you think, wait, what was that? You pause the video, go back to your notes, find the spot where we first were writing what displacement is, read over that definition a few times, then go back to the video and press play again, okay? Because I don't want you to just hear the word displacement in the future and think, yeah, I remember she said something about that. No, I want you to know exactly what displacement is, okay? So what is displacement? It just means change in position, okay? Change in position. How did the position of an object change? That is the displacement. So this is kind of what it is conceptually. Now mathematically, this will have a value. The displacement will have a value. And the way we calculate that value is to take the final position, where did the object end up, minus the initial position, where did the object start. So some of you might be thinking, that I'm making this more confusing than it actually is. You're right. I'm trying to make it super, super, super clear. This is a kind of a simple concept, but I want to really be clear on it. Okay. Now we can write this equation here. Displacement equals final position minus initial position. I can write that in terms of variables. So let's do that. So delta x, this is the variable that we're going to use to represent displacement. So delta x, the change in your x position. What is that equal to? It's just x final. What's x final? That's the x coordinate, right? We're going to have a coordinate system. We're going to have like a number line with different x positions. So x final is your final x position minus your initial x position. So this is x initial. So let's set up a number line. Here's just a very simple number line. If I wanted a more complicated coordinate system, I would have my y-axis going up, right? Let's put in a few more coordinates here. I don't care if it's to scale at all. I just want to help you, what is x final? That's just an x position that you end up at. X initial is just the x position where you started. So let's say we have some guy who starts off right here and walks from a position of x equals 1 meter to a position of x equals 3 meters on our number line. Now this is not a motion diagram or anything like that. I'm just trying to show you where the guy walked. He walked from here to here. What was his displacement? What is delta x for that guy? You might be able to look at it and get it right. Awesome. Let's do it very slowly. X initial, that's where he started, is 1 meter. X final, that's where he ends up. X equals 3 meters, that's x final. Delta x is the difference. It's x final minus x initial, or 3 minus 1. So delta x is 2 meters. So what does that mean? His displacement is 2 meters. He ended up 2 meters to the right in the positive direction from where he started. He ends up 2 meters to the right of where he started. That's what delta x equals 2 meters means. Let's do another one, and why don't you try this one on your own? Let's say the guy starts here and walks over here. What was his displacement? Press pause, work through it on your own. Press play when you want to go through it with me. So he starts at an initial x position of 5 meters. He ends at a final x position of 1 meter. His displacement is equal to x final minus x initial. So that's going to be 1 minus 5. So his displacement, delta x is the displacement, is negative 4 meters. So what does it mean that he has a negative displacement? It just means that he ends up 4 meters to the left, because the negative is the left direction. See, if I go to the left, that's where my negative x values are. If I go to the right, that's where my positive x values are. So negative 4 meters displacement means that he ends up 4 meters to the left of where he started. So I hope that's not too tricky. If it is, watch the video again and you'll probably get it. Let's do one that is kind of tricky. Let's say we have a guy who starts at x equals 0. He runs all the way over here, starts to break a sweat, keeps running. Now he's huffing and puffing, runs all the way over to here, runs all the way back, and stops here. Okay, what was his displacement? And he's standing there looking at you in the face while he's all sweaty and out of breath. And he's like, how did I do? What was my displacement? What are you going to tell him? Well, his displacement is 0. He started and ended in the same spot. It's not, it doesn't matter that he started and ended at 0 specifically. It's just that he started in one position and ended up in that same position. X initial is 0. X final is 0. 0 minus 0 is 0. So here I'm just highlighting that there's a difference between displacement and total distance traveled. How far did he travel? He traveled 20 meters, right? He went 5 meters here, 5 meters back, that's 10 total. 5 meters here, that's 15 meters, and 5 meters back here, that's 20 meters. If he was wearing like a pedometer, or if his phone was tracking his distance that he walked, if he had a Fitbit or something, his Fitbit would say that he walked 20 meters. So this top value, this distance traveled, this is the value that we care about in our daily lives. This is the value that you are always thinking about, talking about. It's the odometer on your car is reading total distance traveled. This is the one that makes sense to us, total distance traveled. In physics, the one that matters to us is displacement, delta x. So as you go forward and start to work on the homework, you might notice that you're kind of getting confused in certain problems. And so come back to this and think, oh yeah, I'm thinking of total distance travel because that's what makes sense because I'm a normal person. But now we're in a physics class, and the values we're going to be using in our equations, the variable that matters is going to be displacement, which in this case for this guy is 0 meters.